Okay, so here I've prepared some questions, past paper questions, to show you a little bit of the functions questions. So here we have a relatively simple question. We have some fx, it's a basic quadratic, and they tell you that this function is even. From that, you'll be able to find b. So we call that even function means f minus x would just be fx. So what that means is you put negative x into the function, so it's a negative x squared plus b negative x plus c. This is supposed to equals to negative x, so the original function. Then negative x squared is obviously just 8x squared, then we have minus bx plus c. Well, then the ax squared cancel out and the c cancel out. So we have negative bx equal to bx. If you add this to the right, it means 0 is 2bx. But for a function to be an even function, this has to be true for all value of x. Okay, so x could be anything. So the question is, how can 2b's times any number to be 0 all the time? Well, the answer is b must be 0 itself. And then we have g being odd. Now this is where, if you haven't learned trigonometry, there's something that you need to know. Turn out sine x itself is odd. It happens to be true that sine negative x is negative sine x. Explanation would be in the trigonometry course, but you can also kind of see that from the graph of sine. Alright, you can see that if you reflect this graph along the x-axis, it will be the same as reflecting the graph in the y-axis. Okay, and they tell you that g is odd. From that, you find out, well, probably 0, right? Okay, we know odd means g negative x should be the same as negative gx. So p sine negative x plus q negative x plus r have to be the negative of gx. I don't think I have quite enough space. So with negative p sine x minus qx minus r. Alright, so sine minus x is negative sine x. This is obviously negative qx plus r. So similarly, the negative p sine x cancel out, the negative qx cancel out, so with r equals to negative r. So 2r is 0, which means r is 0. Alright, and then we suddenly have a function h. Alright, out from nowhere, h is both odd and even. What's h? Well, to be obvious, h is 0. That's the only function in the world where it is both odd and even. Obviously, you could be neither. You could be not odd, not even. But to be both, you have no other choice but to be just 0. Next question would be about the absolute transformation. Another thing that you should know in HL would be doing 1 over of a graph as a transformation. So I also picked this question to demonstrate that. So there is a cubic. I guess it's kind of a background knowledge that you should know cubic look like this. If the coefficient of x cubed is positive, if it's negative, go the other way. Right? They give you in factored form, so they're basically telling you the x-intercepts to be minus 1, 1, and 5. So it's minus 1, 1, and 5. Alright, and this one, if you expand it, the coefficient of x cubed would be positive 1, so it look like this. So you just basically go through the points. right? So I guess it's kind of useful to know if it's a repeated root, or we call it a double root, which is one of the factor is squared. So in this case, we say the -1 is a repeated root. Then the graph is supposed to touch the x-axis, much like if you have x plus 1 squared, then the quadratic would touch x-axis at -1. So it would touch while maintaining this shape, so you probably get something like this. And you probably know what happened if it's a triple root. If it's a triple root, it looks something like go flat a little and then keep going down for cubic. So the thing about double root and triple root are also true for power 4, power 5, so on and so forth. In general, power of 4 graph look like W, with the coefficient of x to the power 4 being positive. If it's negative, it's the other way around. While if it's power 5, we have it look like something like this. If the coefficient of x to the power 5 is positive, and negative the other way around. So you can probably guess the pattern from here. So this is basically fx. Now this question technically is a paper 2, so technically you could have graphed this with a GDC, but it's kind of good to know this kind of stuff, especially with paper 3 now, where you're basically supposed to know, you're supposed to like figure it out in the exams, stuff that are not exactly in the syllabus. So you could have graphed fx with a GDC or by hand, like what I did. You can also graph absolute fx with a GDC or by hand. Alright, there is actually an absolute button on your calculator, or a function in your calculator. You should really figure it out. So if you absolute that, anything below would be flipped up. Anything below will be flipped up. Everything originally on top will be kept the same. So this red one is absolute fx. The question is for what values of x the original function is below, less than means below the absolute 1. So it's basically this part and this part, so that is when x is less than -1, or when x is between 1 to 5. Okay. So we see the first part actually doesn't require a GDC. Second part, now again you can obviously graph 1 minus this with a GDC, but it's actually required in the syllabus that you know how to sketch 1 minus a function, even if it's a paper 1. Okay, so I wish to demonstrate that using this question. So we will have to draw gx first. Gx is a quadratic. If we factorize it, it's probably like this. So the x-intercept is 2, and -3. Y-intercept is what? -6. So it should look something like this. This is -6. It's not the best graph, is it? Okay, a bit better. Okay, not really the best. Okay, so how do you draw 1 over this graph? Okay, turn out it's easy. You literally 1 over every y coordinate of every point. Alright, so for example, when x is 0, the original y coordinate was -6. Therefore, for the 1 over graph, the y coordinate would be -1 over 6. So maybe like here. And at this point, what? It's even lower. So if you 1 minus that, it will be like even closer to 0. Now the interesting thing is, what if originally the y value is 0? 1 over 0, much like a rational function, it gives you a vertical asymptote. So when g was 0, it will be a vertical asymptote for the 1 over graph. So similarly, this will give a vertical asymptote for the 1 over graph. Now also, gx go up to infinity when x go to infinity, and 1 over infinity is 0. So it means that when x go to infinity, the 1 over graph should go to 0. And obviously 1 over positive stuff is positive, so this part of the graph should be on top. This part of the graph should be on top. And anything in between here should be negative, because 1 over something negative is negative, right? So you'll probably guessed that the graph looks something like this, okay? Now the exact shape around this region cannot be easily determined using this method. But if the exam want you to just graph these in the paper 1 by hand, they probably won't be too picky. Okay, so this is how you draw 1 over. And so what? The question is, when is gx, the original graph, below the 1 over graph? So I think is pretty much from here to -3. Okay, can you see the purple bit? And then from here to here, and then also from 2 to here. Now this is where a GDC is really needed for this question. We'll use the GDC to solve for the intersection of the two graphs. So at the end of the day, you do have to graph this. But again, you actually need this ability in paper 1. Now it's also worth mentioning how to draw the squared of a function. Similar to 1 over, you literally square every value, every y value. So if this is gx, you're supposed to be able to draw y equal to gx whole squared. The square all the y value and also squaring have kind of the same effect as absolute value. All the negative would become positive, right? So if you square -6, it becomes positive 36. Alright, so the graph kind of look like this. But the thing is, the positive part would also be kind of stretched up because all the value is squared. Okay, no, well, that's technically not true. It's because when the y value is less than 1, if we square it, it becomes even smaller. But if the value is bigger than 1, it becomes even bigger. So technically, it should go something like this. But technically, the main thing is the fact that all the negative stuff will become positive. This one is quite rare to come up, so it should be fine. The next question, we have something called a domain restriction. It concerns the fact that some function doesn't have an inverse, and if you remember, it comes down to a thing called the horizontal line test. Which, if you remember, is because like the two types of function, there is one-to-one, and there's many-to-one, which means there exists two different x value that's mapped to the same y value. Right, obviously if a thing is one-to-many, then that won't be a function. Alright, so both one-to-one and many-to-one are function, but if you ask which type of function have an inverse, remember inverse would basically be going the other way around, so you go the other direction. But if your function was many-to-one, the inverse would become one-to-many, like this. Then we'll say the inverse is not a function. And that's the same as saying the inverse does not exist. Alright, so we know that any many-to-one function would not have an inverse. And looking at this graph, you realize that this is a many-to-one function. The reason is if you draw a horizontal line test somewhere, you will see that this x value and this x value are mapped to the same y value. So this means this is a many-to-one function. And if a function is many-to-one, it doesn't have an inverse. So you can say this is a many-to-one function, or you can just say it would fail the horizontal line test. Now the thing is, a lot of functions are many-to-one. For example, quadratic itself, y equal to x squared, is many-to-one. So it would make a lot of functions cannot have an inverse, but that would be not nice. So with the concept of restricting the domain, you can basically chop away part of the graph so that the remaining graph would becomes one-to-one. So the normal thing to do is for y equal to x squared, we would chop away the negative side. So we will restrict the domain into x have to be bigger than or equal to 0. Then we will say the inverse is root x. Obviously, this is an arbitrary choice. Technically, you could choose the negative side, so you can restrict your domain into x is less than or equal to 0. In that case, the inverse would be y equals to negative root x. So this question is exactly about that. It says the domain of f has to be restricted, and what is the largest possible domain so that f can still have an inverse. So it basically means you want to chop away the least possible so that the function will still be one-to-one. Alright, so I don't know, should be kind of obvious, especially if I tell you the answer, is when you chop away this part and this part, then this remaining part in the middle would be one-to-one, and that's also the largest, because any larger, if you include a little bit more, then this part would be many-to-one. Right, so this should be quite obvious. So the largest possible domain is when x is between -1 to 3. And so now the graph of g is only this middle part. We are asked to graph the inverse. You graph inverse by reflecting the function along the line y equal to x. So this is y equal to x. So we'll reflect it. The trick would be all the x-intercept would becomes y-intercept. So, and all the y-intercept would becomes x-intercept. So it should look kind of like this. Yeah, that's not too bad. So clearly the y-intercept, that's this one thing stating the coordinate of the endpoint. So this would be an endpoint. The original coordinate was -1, -1. So after flipping, the coordinate would still be -1, -1. Well, for this one, the original point was 3, 1. So after the flip, there will be flip, so it's 1, 3. Okay, I technically draw it too high then. 1, 3. Okay, that should be better. 1, 3. That's how you do something like this. Then we have a sum of root, product of root question. This is one of the time where the middle terms show up, and as you can see, you're supposed to prove it. They even tell you how. But so let's say I will skip that part. I mean, as you can see, just 3 marks. They'll literally just expand. I mean, try once. It's worth doing once. Now what I want to show you is a trick for doing part B. Alright, they tell you that P is -6, Q is 18 for this cubic. They also tell you the roots form an arithmetic sequence. You're supposed to show that one of the root would be 2 using sum of roots and product of roots. Now since p is negative 6, it basically means if you put it in there, negative 6 equals to negative of the sum of roots. Alright, so the sum of roots is 6. And q is 18, so we know that what? 18 would be alpha beta plus beta gamma plus alpha gamma. Then you're supposed to use the fact that the 3 roots is an arithmetic sequence. So what most people would do would probably, assuming alpha is the first term, common difference to be d, so you would say beta is alpha plus d, gamma is alpha plus 2d, and you will probably sub it into both. So we have what? Alpha plus d plus alpha plus 2d is 6, and 18 would be alpha times alpha plus d. You know, beta times gamma, so alpha plus d times alpha plus 2d, so on and so forth. And technically you could do it that way because then you get 2 equations with 2 unknowns. I think I've tried solving this. It would be doable. It's a cubic that you can actually solve using the factor theorem, which basically means you guess the first answer. Okay, but there is actually a trick that would make this question a lot easier. And the trick is, instead of making alpha your first term, you actually make beta your first term. Alright, so you think beta is beta. Beta is the first term, so it's like beta is A. And so gamma would be beta plus the common difference. Alright. Well, then you think, what's alpha then? Well, you think alpha is like the 0th term, the term before the first term, so this is actually beta minus the common difference. Right, then this 3 root would still be arithmetic because you're still getting the next term by adding d. But if you do it like this, the sum of roots, alright, the sum of roots would become beta minus d plus beta plus beta plus d. And so d would naturally cancel out. So 3 beta is 6, and beta is 2. So we have shown that one of the root is 2. Right? We have beta being 2. Yeah, you can see how much easier that is. Normalize cheating. Now to find c, you have to use the product of the root, which basically means you need to find all 3 roots. So naturally we'll make use of the second information. So 18 would be alpha times beta. So this one you really can't cheat that much. You have to use that. So beta times gamma. Gamma is beta plus d plus beta minus d times beta plus d. We now know beta is 2. So we'll expand. I think we should expand. So beta is 2, okay? 2 times 2 is 4 minus 2d plus 4 plus 2d plus, what is this? A minus b times a plus b, right? So it's 2 squared minus d squared. So the minus 2d cancel out. So it's a plus 4 minus d squared. D plus 4 is 12, 6. D squared is negative 6. And I think this is where the trick of, is one of the trick of this question. I did mention in the lecture that you are not supposed to see I that much, but after all, when you're in the exam, you're supposed to know every topic by then, and this is quite unusual, the fact that they mix in a complex number in a question that doesn't seem to be a complex problem. So turn out D is a imaginary number. Okay, if you haven't take the course in complex number, you can probably do it. If not, you can just accept that we can do this. I mean, after all, this is actual math, right? Now, technically, this is plus minus, but the plus minus doesn't really matter much because we have minus d and plus d here. So doing plus minus of d really is just interchanging alpha and gamma. So that doesn't matter. The thing is, we know d. Then we can find c. C, as you can see, would be, so c is negative alpha times beta times gamma. Now here's the trick. Even though that d itself is an imaginary number, c itself is always real. Alright, so we'll take d to be the positive of root negative 6. Okay, so is alpha is 2 minus root negative 6 times 2 times 2 plus root negative 6. Just in case you haven't learned how to deal with complex number, this is like the magic. You don't have to know. You can just like pretend everything would work and do it, and well, turns out everything would work. That's the magic of complex number. That's why we move 2 in front. That's why mathematicians really think complex number is like part of the world, is like really natural extension of the real number system. 2 times 2 is 4 plus 2 times that, whatever that is. Then you have minus 2 times that, whatever that is. Then we have this times this. Negative, positive, negative. And whenever you have root something times itself, you get the thing inside. Right? Hope that makes sense. Negative 7 times negative 7 is 7, right? So negative root 6 times negative root 6 is also just root 6. And so the magic is they cancel out. So no more weird stuff. Plus 6, so it's negative 20 for C. Now knowing this trick part C should not be difficult now. You do a similar trick on the fact that like the different condition that now they're geometric. The condition that P is negative 6 and Q is 18 would still apply, right? Because it's for both parts in D. And obviously you will still need this. This will be a good chance to pause the video, give this problem a try. Answer will be coming 3, 2, 1. So now it should be easy. You take beta to be the first term, so alpha would be beta over L, gamma would be beta times L. And so the sum of root would be 6, same as before. So if you add them up, you should get 6. You probably factor out beta, so we have 1 over L plus 1 plus L being 6. This is where it is already a dead end, so we'll need the other equation. Q being 18 for multiplying 2 of them up and then add them up. So alpha beta would be alpha times beta plus beta gamma plus gamma alpha, so that's beta squared because the over and L cancel out. This time a common factor would be beta squared, so we have 1 over L plus 1. The key is seeing that this and this are the same. So we'll probably take advantage of them, so 18 over beta squared equal to that thing. So we can substitute this into here. So beta times 18 over beta squared is 6. And so what? 18 over beta is 6. Beta is 3. And knowing beta is 3, putting back to here gives 2 minus 2, so it's minus 1. We multiply both sides by L. So 1 plus L squared minus L. So L is probably not nice. We'll probably need the quadratic formula to find L. Well, actually, do we even need L? Maybe not. C is actually just the multiply, the product. So it's negative alpha times beta times gamma. So luckily L cancel out. We actually don't need L. Negative beta cube. Beta was what? 3. So negative 27. So that should be the end of this relatively short course. Again, thank you for having me, and I hope to see you in another course. See ya.